Okay, 6.3. Let us jump into it right away. So 6.3 applications is just going to take what you guys already have learned and are still working on your mastery for 6.1 law of sines and 6.2 law of cosines. So all you're going to do is you're going to notice that I'm going to give you a sort of description of a figure. So sometimes I'll provide you with the figure description if it's really, really complicated. So you'll notice, well, not really, but a little bit more intensive to be able to draw it out and label. I'll provide you with the picture, or if it's pretty straightforward, I'll have you draw your own oblique triangle, okay? But what you're going to have to do with application problems is that I'll give you the triangle and you'll label the sides, but you'll need to classify in order to decide, oh, she needs me to use law of sines, oh, she needs me to use law of cosines to solve whatever I'm asking you to look for, okay? So the number one for our notes is the hardest of the three. So when we push through number one, I don't want you to think, oh my gosh, all the problems are going to look like number one. This is going to be a nightmare. Don't do that to yourself, okay? The homework practice problems that I'm going to give you are much easier than the actual three problems that we do today in applications, okay? Are there any questions? We good? Okay, so let's go and look at number one. So if you would take a moment, read number one and look at the picture and look at all that's labeled. Take about 30 seconds and read that to yourself. Okay. All right, so we'll read together. Read along with me. Angle of elevation. So they have a picture here of a telephone pole. And they said a 10-meter telephone pole casts a 17-meter shadow. So if you look at the figure, here's our pole. They've labeled it already for us. It's 10 meters. And then the 17-meter shadow, that's on the slope of the hill right here. And they've given us 17 meters right here. So it's a bit noisy of a diagram, but just notice that this line right here is 10 meters. And this slope of the shadow on the hill is 17 meters. So that's that first sentence, okay? So a 10-meter telephone pole casts a 17-meter shadow directly down a slope when the angle of elevation of the sun is 42 degrees. So if you look at the picture here, they're telling us that the angle of elevation, which is this angle right here, is 42 degrees. So what you're looking at is this angle right here. This entire angle is 42 degrees. Is everybody good up to there? Okay, so imagine you standing here at point B and you are just looking up at the sun. So your line of sight just rose up, angle of elevation, that's 42 degrees. What they want us to find is theta. Now, if you look at theta, and I will do us a favor here and really, really zoom in to make it a point. Theta is just this angle right here, this little piece right here, okay? Now, what I need you to understand is that this angle entirely is 42 degrees, and they are giving you that, but you are just looking for this little gray piece right here, okay? So as far as the labeling of this diagram, is everybody okay with this? All right, so notice that there are three triangles in this picture, okay? So there's this triangle here. We'll call it triangle number one. Let's call it that white triangle, the one on top of the hill. Triangle two is this grayed out triangle right here. And we can call triangle three this huge triangle right here, okay? So your job is to depict, okay, I can see that I have three oblique triangles. Actually, I have two oblique and one right triangle because this big one is the right triangle, right? I have two oblique triangles and one right triangle. Which one of those triangles is going to help me find this angle right here? So is it triangle one, triangle two, or triangle three? What do you guys think? Two? Okay, I have three people, two. Anybody else want another one? I got 4 twos. Looks like two is the the rule.
Wouldn't it be one oblique and two right triangles? Because
Yeah, that's what I was thinking.
Yeah.
Too.
Yes, you guys rock and you corrected me. Absolutely. One oblique, two right triangles. Thank you. Yes. Excellent. So we are doing the second right triangle right here, right? Okay. So what I want you to do is come over here to the side with me and let us pull out that right triangle, this little one right here. And good job. See, what makes me happy is that I know you guys are actually listening to me. You're just not taking notes. So awesome. I'm correcting me. So here is that right triangle that you can't see. So let me zoom out so we can see better. Okay, so all I'm doing is pulling out that right triangle because this diagram here is a bit noisy, and we're going to label this right triangle with what we know. Okay, so would you guys tell me, what do you know in this space?
At the top line, the
C.
Okay,
C 17.
17. Okay. What else do we know?
The bottom left angle will be theta.
All right, so that's what we're looking for. Excellent. Anything else? Nothing else. So right now, choosing this triangle, do we have enough information to figure out theta? Doesn't look like it, right? Okay, so what other triangle should we try then? The top one. Okay, so let's try this one and see if that's enough. So the actual oblique triangle. So sketching the best that you can. So we're pulling out that top one, something like that. And let's label that triangle and see if we have enough information to figure out what we're looking for. Okay. So what can we label in this triangle?
one of the legs is 10 meters.
Okay. The 10 meters. Top angle is 48 degrees. Very good.
Bottom is 17 meters.
Bottom line is 17 meters. So definitely a lot more information being pulled here, right? Now, are any of those angles actually theta?
No.
No, right? But can any information that can be pulled out of this triangle help us find theta?
Yeah, it literally says in thing 42. Yeah.
Very good. The 42 minus theta, right? So we know that this entire big angle is 42. So if we figure out what this little white angle is, we should figure out what that gray is, right? Okay. So we are going to have as a goal to look for this angle, whatever that angle is going to be. So I'm going to put a question mark by that angle. Now, when you guys get to this point and you guys use this, what I need you guys to do is label the corners of your angles with any capital letters that you want. So what are the capital letters y'all want to use?
ABC.
The ABC? Sure. Oh, I didn't even notice. See, I'm dropping the ball all over the place. Right here, Kennedy just told us that we actually already have them labeled. So ABC we are going to use because it's already there. Thank you. The other class didn't catch it. So ABC. All right, so we are actually looking for angle B, are we not? Now, what you are going to do, we need to find angle B. We have to decide what law we are going to use, and that has to be decided by classifying our triangle, okay? So classifying means telling me what was given to you in this triangle. So what was given to us?
Wouldn't it be side angle?
Okay, so you're telling me so far that 2 S's and an A were given, right? So is it you did tell me it's the first one. Is it side angle or side angle side?
Side angle.
Side angle, right? That angle has to be trapped between the two sides, and this angle is not trapped between these two sides, right? So yes, SSA. So SSA is law of sines or law of cosines? Law of sines. So law of sines is the approach that we will have to take, okay? Now, SSA is an ambiguous case, but I'll tell you this, when it comes to application problems, just know it's always going to be one solution, okay? So if you end up with an ambiguous case of law of sines for applications, it will just be one solution. You do not need to go searching for another solution. Are we good? Okay. Law of sines. So we're looking for angle B. So obviously we start sine of angle B because that's what we're looking for over what goes underneath angle, sine angle B.
Angle B.
So that's what you're looking for. So what goes here?
10,
Why?
because it's across from B.
Very good. So little 10 is little b, right? And it, lowercase b, goes underneath my sine capital B. So it will be 10. So the side right across from what you're looking for equals. Now the fraction here on the right side of the equal side is always the pair that we do know. So what do we put?
Sine 48 over 17.
Yep, which is sine A. You're correct, Zach, over 17, right? So we are looking for capital B. So we put that first in our numerator. So sine of capital B over 10 equals what we know. So we will always cross multiply and then divide. So because we're solving for capital B, we have to take the inverse, okay? This sign right here, I'm going to put it really dark here to remind you that you have to do something with it. What are we going to do with it? Move it over, and it becomes what? Sine inverse. Very good, Ken. So we cross multiply 10 times the sine of 48 degrees divided by 17. So go ahead and find capital B. And if you would, round to 2 decimal places. Right.
You said round to 2 decimal
Yeah.
places?
Let's see. Let me call on Dylan. By any chance, do you have an answer yet for B?
25.92.
All right. Thank you, bud. 25.92. Okay. All right. So is that our final answer?
That's what I got.
Yep. Everybody got 25.92? All right. Is that what's being asked for in our story problem? All right. What do we need to do?
We need to subtract 25.92 from 42.
All right. So remember that we were looking for theta. Excellent. So I can't think. 42 minus the 25.92. Very good. And Charlie, what you got? Whenever you're ready. All right. Okay. Excellent. Okay. So every given application problem, classify it so you know which one, and then solve using whichever formula needs to be used, okay? Any questions on number 1? Good. Silence. We're golden. Okay, so let's move on to number 2. Number 2, another geometric figure is being given to us. Determine the angle theta in the design of the street light shown below. So notice what's labeled. Okay, on this one's not complicated in the sense that there's more than one triangle given to us. There's only one oblique triangle in the picture. So you will just jump right into going ahead and figuring out what the classification is based on what's given in the image. Okay? So what will it be on this problem?
Side, side, side.
Very good. 3 side lengths were given, right? Side, side, side were the 3 given side lengths. Very good, which is law of cosine. Okay. So recall that when it comes to law of cosines, we are having to use 2 different formulas, right? Or we were having to decide between 2 different formulas. Now, this picture does not have the corners or vertices labeled, so you have to do that yourself. It's completely random, so your labeling might differ from somebody else's. It's okay, all right? But just to keep all of us homogeneous here, what do you want to label? Let me see. I'm going to ask Alec. What do you want to label this corner? A. And this corner? B. And so I guess you're going with C on this other one? All right. So A, B, C. And if you labeled yours different, you don't need to change it. It doesn't matter, okay? So based on the labeling, if they're asking us to find angle theta, what are we looking for? Angle B. So find angle B. Okay. So law of cosines. Again, you guys will be provided with formulas. But I'm going to just come over here and provide us with what you have from your note-taking guide. So angle B formula is going to be this one right here, the capital B. And do not forget, with alternative form, you guys are always going to take the cosine inverse to isolate that capital B, okay? So again, don't forget that. So I'm just going to write the formula here as you guys, actually I'll come down here at the bottom. Go ahead and solve for capital B if you haven't started doing so as yet, okay? So I'm just writing out the formula. And reminding you here.
Is that 4 1/2?
Yes. So if you prefer writing 4 1/2 as a decimal value to make it easier to type in the calculator, feel free to do so. Okay, if you're ready, look up and check your work. Okay. Any questions on this one? Okay. Again, just to remind you guys of the pattern, please remember if those two numbers that are first mentioned in the numerator will always match these 2 numbers, okay? So just a reminder on that law of cosines. Okay, let's go tackle that last one if nobody has any questions. Alrighty, so last one down here. All right, take about 10 seconds there, read that 2-sentence paragraph. Look at the picture. All right, so we have a 100-foot vertical tower to be erected on the side of a hill that makes a 6-degree angle with the horizontal. So they told us in the picture that this tower here is 100 feet tall. And it's shown right here using this imagery right here. And then they're telling us that this hill is actually a slanted hill and it slants at a 60-degree angle. So all that just means is if I were sitting at a horizontal means 0-degree plane, like a flat surface. What happened is that this incline just slanted a little bit to a 6-degree angle, okay? So they're just talking about that little shift in that measurement. It slanted 6 degrees, okay? Find the length of each of the 2 guy wires. These are guy wires right here. That's a guy wire, and that's a guy wire, okay? They also told us that from the bottom of this tower to the guy wire on each side, they both are the same length of 75 feet. So they're going to want us to split this diagram into 2 oblique triangles. Okay, so to help visualize it a little bit more, I'm going to use a highlighter here. We're going to look at this guy wire first. So this is the triangle that I need you to focus on for right now. Okay, so this one right here is the one I want you to focus on. And we're looking to figure out how long is that guy wire there on the left-hand side. And then we'll just do the right-hand side afterwards, okay? So if you can focus on that little yellow triangle, we're gonna go down below where there's space provided and redraw just that oblique triangle so that it's less noisy, so to speak, okay? So I'm gonna hide our paragraph a bit since everything is pretty much pre-labeled for us. I'm gonna come down here and translate that triangle over here for a sketch for myself. And then I have the tower. And then this seems to go a little bit longer. So as good as a sketch, as close as a sketch as you can to the previous one. Okay. So this is an oblique triangle. And when you can, go ahead and label what you do know in this triangle. Okay, so you would have labeled this here 75 from the distance from the bottom of the tower to the guy wire. And then they told us that the tower was 100 feet tall. Okay, so as for starters, you could have done that. Okay. Now we know we're looking for the length of this guy wire, so I'm going to put a question mark here showing that's what I'm looking for. Okay, I'm looking for the length of that side. So we know from what we've been working with law of sines and law of cosines, it's always 3 things that are given to you. You always have to have a minimum of 3 things to be able to even start law of sines or law of cosines. And right now only have 2 things that's obvious to us. Is there anything else in this story problem that can help us by providing us some extra information?
Maybe the 6 degrees.
Okay, the 6 degrees, right? It's supposed to help us. The angles, very good. So how does the 6 degrees help us here in determining an angle in our picture?
We can use it with the 100 foot
With the, in which way?
to find the angle, to find the hypotenuse.
So, yes.
Like, you know, you have to have like 2 that are finished. So like, let's say that these are the 2 that match up. Let's say that this was like B and little b.
Uh-huh.
B and little b.
Very good. So what Jelena is saying is she knows that we probably are going to use the 6 degree to find an angle because we need to have a pair to be able to set up, for instance, law of sines, right? So what the 6 degree is going to help us find which one of these angles do y'all think?
The bottom one.
Bottom left.
This bottom left right here? Is that what you're saying? Okay, so how? Oops. So in the picture above, this is where our angle, this here is the flat surface, right? And then they said there's an incline that becomes 6 degrees like that. What angle changed?
The 90.
There you go. So right here, there you go. So here, our tower, if you look here at our tower, what is that right now? Isn't that 90?
Yeah.
Right? But it actually shifted down 6 degrees, did it not?
90 minus 6.
And it's 90 plus 6.
Because it widened,
Oh, that's right.
right? Does everybody see that? Okay. So this angle right here went from 90 to 90 plus 6. So it became a 96-degree angle. Okay, because the horizontal was like this. It was horizontal at 90 degrees and it shifted 6 degrees down. Okay, so if we look at this classification, what is it going to be?
SAS.
SAS, very good. The angle is trapped in between both sides, right? All right, so SAS is which law?
Cosine.
Law of cosines. All right, so which one of these do y'all want to label A? Bottom, top, middle,
Top.
top. All right, A. Which one of these is B?
Left.
Left, bottom. Okay.
Really made that confusing, guys.
All right. So, what are we looking for? We're looking for that. Yep. So find little c. Okay. So if you go to you guys told me law of cosines, right? I forgot to write this down. So if you go to law of cosines, are you going to use the alternative form or the standard form? Standard form. Very good. Standard form is for missing side length. So we're looking for little c, so I'm going to write out this formula for you guys, and then you guys substitute. So c squared equals a squared plus b squared minus 2ab cosine of capital C. So go ahead and take a moment to do that one. Okay, if you are ready, you can look up and check your work. Okay. Okay, so don't forget. So don't forget to put this right here. Don't forget to square root. So you need to square root that answer you got. So just do second square root and then copy and paste. All right. All right, if you got 131.12, I want you to, and you have no questions, I want you to take the time, and you can work with your partners, find the length of the other guy wire on the other side. Okay? I want you to go find the length of the other guy wire. So I'm going to highlight this in purple, and maybe you will see it on this one. So now you're looking for this one. Okay. Okay. So if you can kind of see that purple, go ahead and redraw the new one.
He's trying to.
This is our last problem. Okay. So you're looking for that guy wire now. So this is the purple one. So it's going to be something different, a little something different. So what do you think is going to be the difference? Very good. I will. Okay, if you are ready to look up and check your answer, it is displayed. So hopefully you caught on that this time the angle of the guy wire and the ground decreased in size. So you would have done the 90 minus the 6 degrees instead. And so that included angle would have turned into an 84. Okay, so it's still an SAS classification. And if you kind of maintain the same pattern of the lettering that you did in the previous one, you would have arrived to the 118.56. Okay. Are there any more questions? Is everybody okay? We're good? Okay.